Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will talk about frequency modulation and amplitude modulation from Cambridge A2 Physics. In this video, our main focus will be on frequency modulation. I'll explain you how to find amplitude, minimum frequency, maximum frequency, and the rate at which frequency of FM wave changes with the help of past paper questions. First of all, let's try to understand what is amplitude modulation. For amplitude modulation, the first thing we need to understand is that the amplitude of the carrier wave is made to vary in synchrony with the displacement of the information signal. What exactly it means? It simply means that the amplitude of this modulated wave, it is depending on information signal and it is depending on amplitude of carrier wave. Let's say the amplitude of this carrier wave is AC, amplitude of signal is AS, and amplitude of this modulated wave is AM. Now simply you can see from here, when the amplitude of signal is positive, the amplitude of this modulated wave, this is greater than amplitude of carrier wave. So it simply means when the amplitude of signal is positive and increasing, amplitude of carrier wave will be increasing, and that will be the amplitude of amplitude modulated wave. And when amplitude of signal is negative, so amplitude of carrier wave will decrease and amplitude of modulated wave also decreases. Let me write down in a simple way so you can understand better. So let's say here we have amplitude of modulated wave and amplitude of modulated wave. It is depending on amplitude of carrier wave and it is depending on amplitude of signal. When amplitude of signal is increasing and it is positive, amplitude of modulated wave will increase. And when amplitude of signal is decreasing and it is negative, amplitude of modulated wave will decrease. If we look at the second point is simply telling us that the frequency of the carrier wave does not vary. It simply means that the frequency of modulated wave is the same as frequency of carrier wave. So we can simply write down the frequency of modulated wave is equal to frequency of carrier wave. Next point is simply telling us that the variation in the amplitude of the carrier wave is depending on the displacement of the information signal. It simply means that when the displacement of information signal, this is bigger, the change in the amplitude of carrier wave will be bigger. And when displacement of information signal is small, then the change in the amplitude of carrier wave will be small. Or we can simply understand this one from amplitude modulated wave. When the displacement, if this displacement is bigger, the change will be bigger, mean the amplitude of this one will be bigger. If amplitude, or we can say the displacement of information signal, when this is small, the change in the amplitude of carrier wave will be small, and we will also see the small change in the amplitude of modulated wave. So simply we can write down that the change in amplitude of modulated wave, this one is depending on displacement of information signal. Depending on displacement of information signal is depending on AS. So it means this is amplitude of information signal and here is amplitude of modulated wave. Next point is telling us the rate at which the carrier wave amplitude varies is equal to the frequency of the information signal. Rate simply means that the number of times the amplitude of modulated wave increase, decrease, and then increase is depending on the frequency of the signal. Or we can simply say that rate of change of amplitude of modulated wave, it is equal to frequency of signal. Now we have good understanding of amplitude modulation. If your concept about amplitude modulations are very clear, then frequency modulation is very simple to understand. Frequency modulation, when we talk about frequency modulation, it simply means that in this case frequency of carrier wave changes. So this is the first point you need to understand. So when we were talking about amplitude modulation, we said amplitude of carrier wave changes depending on displacement of information signal. But for frequency modulation, frequency of carrier wave is changing based on amplitude of information signal. Now, the first point simply telling us frequency of the carrier wave is made to vary in synchrony with the displacement of the information signal. So in this case, we can see here when this displacement, this is positive, the frequency is increasing. When this displacement is negative, frequency is decreasing. Now, next one. Second point is simply telling us the amplitude of carrier wave does not change. So this is frequency modulation. So in this case, frequency of carrier wave change, but amplitude does not change. So we can simply say that in this case amplitude of modulated wave is the same as amplitude of carrier wave. So you can see here this is our carrier wave, it has amplitude AC, and our frequency modulated wave has amplitude AM, and these two are equal. Now let's move on to next point now. Third point is simply telling us the change in the frequency of the carrier wave is depending on the displacement of the information signal. So it's simply telling us is that when the displacement of the signal, this is positive, frequency of modulated wave, this is increasing. And when displacement, as you can see here, when displacement of this signal, this is negative, frequency of modulated wave is decreasing. Frequency of modulated wave is decreasing. So this is what this point is telling us. Last point is simply telling us the rate at which the carrier wave frequency is made to vary is depending on the instantaneous frequency of the signal. So it simply means that number of times frequency of carrier wave, or we can say frequency of modulated wave, increase, decrease, and increase again. This is depending on frequency of the signal. If signal has more than one frequencies, it will depend on instantaneous frequency of the signal. So this is simply it means by rate. We can write down rate of change of frequency, rate of change of frequency, modulated wave frequency is equal to frequency of signal. Let's try to answer this question now, and for this question it is given to us that a carrier wave is frequency modulated. So we need to describe what is meant by frequency modulation. Frequency modulation simply means that the frequency of carrier wave will change with displacement of information signal. We have discussed a lot about this one. Let me show you how to write answer for this one so you can get 2 marks. This is how you can write your answer for this question. So if you write this one, you will get 2 marks. Now let's move on to next one now. If we read this question carefully, it is given to us that carrier wave has frequency, and this is frequency of carrier wave is given to us, and amplitude of carrier wave is also given to us, that is here, and carrier wave is modulated by signal and frequency of the signal is given, so we can say this is frequency of signal, and amplitude of signal is also given, we can say this is amplitude of signal. Frequency deviation is given to us of the carrier wave, and this is 20 kilohertz per volt. It simply means that the frequency of carrier wave will change by 20 kilohertz when amplitude of signal changes by 1 volt. So this is frequency deviation. Mean how much frequency of carrier wave will change depending on amplitude of the signal. So if amplitude of signal changes by 1 volt, frequency of carrier wave, this will change by 20 kilohertz. If amplitude is positive, frequency of carrier wave will increase by 20 kilohertz per 1 volt, and if amplitude is negative, frequency will decrease by 20 kilohertz per 1 volt. Now, first part is simply asking us determine for the frequency modulated carrier wave, what is the amplitude of frequency modulated carrier wave. So we understand in frequency modulation, amplitude of carrier wave does not change. Only frequency of modulated wave change. So we will simply say amplitude of frequency modulated wave is the same as amplitude of carrier wave, and amplitude of carrier wave is already given here, so this is simply equal to 5.0 volts, and that is our answer. Second part is simply asking us, we need to calculate the minimum frequency of the frequency modulated wave. Minimum frequency we can simply calculate. If we have frequency of carrier wave, we just simply need to subtract frequency deviation. So I will just write down here, this is frequency deviation, and this one we need to multiply with amplitude of signal. So if we plug in values, we can simply find out, because frequency of carrier wave is given, that was 750 kilohertz, and frequency deviation was given, that was 20 kilohertz per volt, and amplitude of signal is also given, that is 1.5 volts. Now if we simply solve this one, our final answer will be 720 kilohertz, and this is the minimum frequency of frequency modulated wave. So our final answer is 720 kilohertz. Now next part is asking us maximum frequency, so simply we need to add. So again we can write down maximum frequency, that will be equal to frequency of carrier wave plus frequency deviation. So here is frequency deviation, and we need to multiply this with amplitude of signal. So just we need to plug in values now. You can see this is 750 kilohertz plus frequency deviation we have, that is 20 kilohertz per volt, and we simply need to multiply with amplitude of signal. Amplitude of signal was 1.5, that is given to us 1.5 volts, and in this case our final answer, that will be 780 kilohertz. So this is our final answer. Last part is simply asking us the number of times per second the frequency modulated wave changes from its minimum value to maximum value and then back to minimum value per second. You can see here, if you look at this frequency modulated wave, you can see frequency here is maximum, then frequency becomes minimum, and then here frequency is maximum again. And this is depending on frequency of the signal. So this is depending on frequency of signal. If you look at this one, when amplitude is positive, frequency will be maximum, and when amplitude is negative, frequency will be minimum. You can compare here, and frequency will be minimum. And then again, when amplitude is positive, frequency will be maximum. So it simply means that the rate of change of frequency, it simply depends on frequency of signal, and frequency of signal is already given to us, that is 7.5 kilohertz. So our final answer is 7500 per second. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will talk about communication systems from Cambridge A2 Physics. In this class, we will discuss what is bandwidth, advantages and disadvantages of greater bandwidth. We will also talk about maximum and minimum frequencies and amplitude of a frequency modulated wave. First of all, let's try to understand what is meant by bandwidth. Bandwidth simply is the range of frequencies of signal, or we can simply say is the range of frequencies occupied by modulated waveform. Let me explain to you this one with the help of amplitude modulation. Let's say we have carrier wave that has frequency Fc, and we have information signal that has frequency Fm. If we look at this frequency spectrum, you can see on one side we have upper sideband, and the frequency of upper sideband is simply equal to sum of these two frequencies. And this side we have lower sideband, and the frequency of lower sideband, that is simply equal to frequency of carrier wave minus frequency of signal. Now if we subtract frequency of lower sideband from frequency of upper sideband, we can get bandwidth. Bandwidth simply tells us that there is a range of frequencies occupied by modulated waveform. Even there is a one frequency for carrier wave. Now let's try to understand how we can calculate bandwidth. Bandwidth simply is equal to the difference in frequency of upper sideband and frequency of lower sideband. So we have frequency of upper sideband. So here is frequency of upper sideband, and we need to simply subtract frequency of lower sideband. If we subtract, we will simply get that is equal to 2 times of frequency of information signal. Now you can see here, if you need to calculate the bandwidth, even frequency of carrier wave is not given, you can still calculate bandwidth by just multiplying frequency of signal by 2. It's very important point. Sometimes in question they will not give you frequency of carrier wave, but still they will ask you to calculate bandwidth. So simply you can multiply information signal frequency by 2 to calculate bandwidth. So bandwidth is very important concept to understand. Sometimes it is called bandwidth of station. So that is also the same thing. Bandwidth of station means that one station can only only operate in that range. No other station can operate. If another station also use the same bandwidth, there will be interference, and that is not good. This is how we can define bandwidth. Simply you can say range of frequencies of signal. Let's move on to second part now. Second part is simply asking us for one advantage and one disadvantage of a greater bandwidth. First thing what we need to understand about bandwidth is that bandwidth affects the quality of signal. If the bandwidth is greater, quality of signal will be better. If the bandwidth is lower, quality of signal will be lower. And the rate of transfer of data also depends on bandwidth. If the bandwidth is greater, rate of transfer of data will be greater. And if the bandwidth is lower, rate of transfer of data will also be lower. And if you think about music from FM station and music from AM station, quality of music of FM station is much better than AM station because the bandwidth of FM is greater than bandwidth of AM radio stations. So this is how we can write advantage. Now let's try to write down one disadvantage of a greater bandwidth. Greater bandwidth actually affects number of stations. For a fixed frequency range, if we increase the bandwidth, number of stations will go down. It means there will be fewer number of stations. So we can simply say the disadvantage is that fewer stations means less number of stations. So this is disadvantage. For part B, it is given to us that a carrier wave has a frequency of 650 kHz and amplitude of carrier wave is 5.0 volts. We can simply say amplitude of carrier wave is equal to AC and frequency of carrier wave is equal to FC. Question is telling us that the carrier wave is frequency modulated by a signal of frequency 10 kHz, and this is frequency of signal, and amplitude of signal is also given, that is equal to 3.0 volts. We can say this is amplitude of signal. Frequency deviation of carrier wave is also given, that is equal to 8 kHz per volt. It simply means that the frequency of carrier wave will change by 8 kHz when amplitude of signal will change by 1 volt. And the frequency will increase, means frequency will increase when amplitude of the signal is positive, and frequency will decrease when amplitude of signal is negative. This is very important piece of information. We will need this one. Now, as it is given to us that the frequency modulated carrier wave, we need to find its amplitude. If it is frequency modulated carrier wave, then the amplitude of modulated wave is equal to amplitude of carrier wave, and in this case amplitude of carrier wave is equal to 5.0. so this is amplitude of modulated wave. If frequency modulated wave, it simply means only frequency will change. So very important thing we need to understand, frequency modulated wave means that frequency of carrier wave will change and its amplitude will not change. Now let's move on to second part. It's asking you find the maximum and the minimum frequencies of frequency modulated carrier wave. So if you look at this frequency modulated carrier wave, you can see this is maximum frequency and here frequency is minimum. We need to find out these two frequencies. If you look at this one, I have already explained to you the frequency will increase when amplitude of signal is positive. It will increase. As you can also see here, the frequency is increasing, and frequency will decrease when amplitude of signal is negative. How much it will increase? It will increase by 8 kHz when amplitude changes by 1 volt. And if amplitude is 3 volt, it means the frequency of this modulated wave, means change the frequency of carrier wave, this will change by 24 kilohertz. It will increase when amplitude is positive. It will decrease when amplitude is negative. So we just need to understand these informations and then we can answer this second part. So we can simply write down frequency maximum. This is equal to frequency of carrier wave plus this is equal to frequency deviation. We can say this is equal to frequency deviation multiplied by amplitude of signal. And if we simply plug in values, we can find out our final answer. This is 650 kilohertz plus we have frequency deviation that is 8.0 kilohertz per volt, and if we multiply this one with signal amplitude, that is 3 volts. Our final answer in this case will be 674 kilohertz. Now let's try to find out minimum frequency as well. For minimum frequency, simply we have this is frequency of carrier wave. We need to minus now. So we will simply write here frequency deviation multiplied by amplitude of signal. So in this case we will get this is frequency of carrier wave that is equal to 650 kilohertz minus we have frequency deviation that is 8.0 kilohertz per volt. We have to multiply by amplitude of signal that is 3.0 volts, and in this case our answer will be 626 kilohertz. So we can write down maximum frequency that will be 674 and minimum frequency of frequency modulated carrier wave that will be 626 kilohertz. So this is how you can answer. So there are two ways. One, if you understand concept, you don't need to use the formula. The second way, or we can say the safe way, you can simply use this formula to calculate maximum frequency and to calculate minimum frequency. Only difference is that you need to add, and for minimum frequency you need to subtract. Third part is simply asking us to calculate minimum time between a maximum and a minimum transmitted frequency. If we look at modulated carrier wave, we can see frequency is maximum here and frequency is minimum here. Frequency is maximum when amplitude is positive and frequency is minimum when amplitude of signal is negative. So minimum time simply means we need to find the time when the amplitude is positive and when amplitude is negative. So simply we need to find out this time, and this time is equal to half of time period. So we can simply say half of time period of signal that is equal to T minimum. But in this question we have frequency of the signal Fs is given to us. We can find out first of all time period of signal. So this is equal to 1 over frequency of signal. So if we just divide 1 by frequency of signal was given to us, that was 10 kilohertz, and if we divide this we will get this is 1 times 10 to minus 4 seconds. Now we need to find out T minimum, and T minimum is equal to half of time period of signal. Simply we need to divide Ts by 2. We can simply say this is 1.0 times 10 to minus 4 and this is divided by 2. If we divide by 2 time period of signal, we will get our final answer is 5.0 times 10 to negative 5 seconds. So this is our final answer.